So in this section or this series of videos, we're going to introduce the idea of unit circle trigonometry. So we know already about trig function values based on right triangles, but we are introducing the unit circle in trigonometry as a way to be able to identify that circular rotation. And so if we have a center point that we are pivoting around and we want to know how much an angle has rotated around that center point, then that's kind of this idea behind circular rotation or circular trigonometry. And we can use the idea of our radian measure and degree measure to both be able to talk about the unit circle. Before we go on, we want to be reminded about reference angles. Remember, we introduced reference angles in a previous section, and reference angles had to do with acute angles. So if we're thinking of acute angles, we're always going to think about those angles that are between 0 and 90 degrees, or in this case, we can add in radian measures, so we have values between 0 and pi over 2. And so any value that falls in the first quadrant would be considered our reference angle. And using our reference angles, we can add or subtract off of the x-axis to identify the coterminal angle, if you will, or the angle that we're actually interested in. So what I want to make sure that you remember and that you understand is that we are always adding or subtracting off of the x-axis. Never add or subtract off the y-axis. So in radian measure, that's going to mean for us that we're always adding or subtracting from either pi or 2 pi. Or in degree measure, we would always be adding or subtracting from 180 degrees or 360 degrees. So let's move down here and we're going to take our what we call our unit circle and we're going to fill this unit circle in. Now ultimately, the unit circle is comprised of some special angles that occur so often that it's useful for us to memorize them. And we're going to see that even though there's all this information on the unit circle, it becomes important to identify symmetry and reflection, and then it's going to make it easier for us to memorize this unit circle. So we are going to work smarter and not harder in this way. Now, if you've got your notes with you, I would encourage you to get some different colors to be able to fill this in. It makes it a little bit easier to identify because I'm going to try to use some colors here with you as well. We are going to come through here and we're going to talk about the degree measures first. So we know for a fact that degree measures, if I have an angle starting at its initial point here on the x-axis and it hasn't moved anywhere, I have rotated 0 degrees. And if I rotate halfway around, I'm at 180 degrees. And when I rotate all the way around, I'm back at 360 degrees. Now, in radian measures, we know that that would be 0 radians at the initial. Halfway around the circle, we are at pi. And all the way around the circle, we have rotated 2 pi in radian measures. Now we can identify the ordered pairs here as if we are thinking of a unit circle. What we mean by a unit circle is we're going to take this point that's rotating around the outside of this circle and we are going to say that this circle has a radius of 1. So if this point out here on the edge of my circle is a radius of 1, or the point is along that circle, then we know that the distance from the center to the edge of the circle in its ordered pair notation would have to be 1 in the x direction, 0 in the y direction, because it's sitting here on the x-axis. Now if that point rotates all the way around or halfway around the circle over here to pi, then the location, the ordered pair representing this location would now have to be -1, 0. So those are kind of straightforward there. How about we back up? And we know that, first of all, we know that these values of 0 and pi or 0 and 180 and 360 are all what we called in a previous section quadrantal angles. Now we want to identify the other quadrantal angles that we know. We know that if we are up here at halfway in between 0 and 180 degrees, that this has to be 90 degrees. And if I rotate around here, then halfway in between 180 and 360, I am at 270 degrees. So the reason I'm pointing it out that way is because now if we think about what the radian equivalent is to 90 degrees, let's take this idea here that initially I'm at 0. If I rotate over here, I'm at pi. Well, what's halfway between 0 and pi? Hopefully you're thinking to yourself, that's got to be pi over 2. Now, let's look down here. If I am between pi and 2 pi, halfway between pi and 2 pi takes me to 3 pi over 2. And that's how we're going to come up with these radian measures, is kind of these fractional values as we're working on filling in our unit circle. Now, we want to make sure that we come back and fill in the ordered pairs represented by these other two quadrantal angle measurements. So here at 90 degrees, remember we have a point on the edge of our circle that has rotated up here to pi over 2. The radius of this circle is 1 unit. So we have 0 for the x coordinate and positive 1 for the y coordinate. Down here at 270, we would have rotated 0, or the point would be located at 0, -1. So here we have the beginnings of our unit circle, and we have the 5 quadrantal angles that we've discussed before. Now we're going to identify next another angle that is useful here. It's a very common angle, and I'm going to draw a line here through that angle measurement right there, and notice how if I keep going that this line goes all the way through down here to the opposite side of the circle. And I can also come back here and I can draw a similar line in that direction right there. What I'm trying to identify here is the fact that if I rotate, here I have a point that rotates up here to this angle in that direction, that would be the same rotation as if I came off of the x-axis and rotated down here. That's exactly the same angle measurement. That's going to be important for us because it's going to help us identify this idea that my information is reflective and symmetric. So what angle is this that I have rotated here? Well, that angle of rotation is 45 degrees. So if I'm 45 degrees here in the first quadrant, this would be considered the reference angle because it's the acute angle in the first quadrant. Now, how do I determine then what is the angle? Maybe I should say it a little bit differently. What would the angle be if I rotated all the way around the circle and stopped here? Now we know that this is related in some way to this 45 degrees. If I tell you that this angle measurement here is 45 degrees, that would be the reference angle because that's the acute angle from the first quadrant. And I know that the value then of this rotation, if I started here and I rotated all the way around and stopped at that location, the value of that would have to be 180 degrees minus 45. Remember, reference angles are the small angles that we are either adding or subtracting to 180. So I like to think of it as I rotate all the way around to 180, but then I back up 45 degrees, and that puts me here at 135 degrees. Okay, using that same concept, we would come down here, and now I want to know, okay, if I have this point, I'm going to rotate all the way around and stop here in the third quadrant. We would be rotating. This is my acute angle. This is my 45 degrees that I have here. Okay, and so I would rotate all the way around to 180, but I would keep going 45 more degrees because that's my reference angle. So 180 plus 45 is 225 degrees. And then we have this final angle here. So if I rotate all the way around the unit circle, but I stop here in the fourth quadrant, now this is no longer adding or subtracting to 180, but instead notice the small angle here that if I am now subtracting from the x angle, this would be 360 minus 45. So 360 minus 45 ends up being 315. Okay, so that's how we're using the reference angles. Okay, and maybe it would be helpful if I drew this line like that. So here we have an angle of 45. Here we have an angle of 45. In the third quadrant off of the x-axis, we also have that angle of 45. And in the fourth quadrant, again, off of that x-axis, we have this angle of 45. That's why we call them reference angles, to be able to take the information we know from the first quadrant, and you can see that that angle is kind of reflected around the unit circle. Now let's go back in and figure out, well, if we know what the degree measurements are as we move around the circle, what is the radian measure? Let's go back to our fractional values here. We know that if our point is in the first quadrant between 0 and pi over 2, well, 45 degrees is halfway between 0 and 90. So what value is halfway between 0 and pi over 2? Hopefully you're saying, well, that's got to be pi over 4. So 45 degrees is equivalent to pi over 4 radians. Now, what can we do with our reference angle here in terms of identifying the radian values in the rest of the unit circle? So we're going to let the denominator here guide us. So the denominator of my reference angle is a 4. So we know that this is 1/4. We'll just shorten it to be 1/4. So I can't add or subtract fractions unless I have a common denominator. We know that in order to get the value of this angle here in the second quadrant, we would be subtracting from the x-axis. The x-axis in radian measure now over here at this location is considered pi. So in terms of a denominator of 4, pi is equivalent to 4/4. So 1 pi is the same thing as 4 over 4, 4 pi over 4. So if I go all the way around to 4/4 and I back up 1/4, that leaves me at 3 pi over 4. Okay, so I'm letting the denominator here make it easier for me to do a little mental math. So if I rotate to pi or 4/4, I back up 1/4, that gives me 3/4. Now, in the third quadrant, rotate around to 4/4. This time we're going to add 1/4. So 4/4 plus 1 has to be 5/4, or 5 pi over 4. So I'm just dropping the pi when I talk about it for a second. So 5 pi over 4 is the same thing as 225. How about when we are over here at 315, right? We're in the fourth quadrant. If I rotate all the way around to 360, well, 2 pi is the same thing as 8 pi over 4. 8 divided by 4 is 2. So one complete revolution around this unit circle in terms of the denominator 4 is 8 pi over 4. So that makes it a little bit easier. If I rotate all the way around to 8 pi over 4, subtract 1/4, that leaves me at 7 pi over 4. And so that's how I get both the radian and the degree measures for the fourths as I rotate around the unit circle. Now, what is the ordered pair related to this angle of 45 degrees. This is where we're going to back up just a little bit, and we're going to think about some of the special triangles that we looked at. We know that if I am here at pi over 4 and I were to drop down a perpendicular line from this location, right, which is how far in the y direction technically I have rotated. But anyway, so I know that this is a 45-degree triangle, right? We know from previously that if this is 45, this up here also has to be 45. And because of that, the radius of, or the hypotenuse of any right triangle that's 45, 45, 90 has to be a radius of square root of 2, because it's 1, 1, square root of 2. So let's think about our triangle again. If we have our triangle who has a leg of 1, a leg of 1, and a hypotenuse of the square root of 2, but I'm trying to fit this on my unit circle, I actually need the radius, or this hypotenuse here, to be scaled down to be a radius of 1. In other words, if I was looking, let me see if I can draw this over here. If I was looking here, I would have now this triangle who is supposed to have a hypotenuse of 1. I still know it's a 45-45 triangle, so I need to scale back my dimensions. I can do that by dividing by the square root of 2. Square root of 2 divided by the square root of 2 is 1. But I can't just do that to this hypotenuse of the triangle. I would have to do it to every leg and every side of that triangle, because you have to keep it balanced, right? So now if I scale this entire triangle back by a factor of the square root of 2, then that gives me new dimensions of my 45-45 degree triangle. I have a value in the x direction of 1 over the square root of 2, and I have a value in the y direction as, again, 1 over the square root of 2. Now, we're going to see, and we're going to see this a lot, that we don't typically leave these ordered pairs. We don't typically leave our answers with a radical in the denominator. So this 1 over the square root of 2, in order to rationalize the denominator here, or get the radical, the square root symbol out of the denominator, we would have to multiply top and bottom by the square root of 2, giving me the square root of 2 over 2. That's equivalent to this value here. So all of that is to say that now, if I'm thinking of an angle rotation of 45 degrees with a hypotenuse, or with a radius of only 1, then the location of this ordered pair has to be the square root of 2 over 2 and the square root of 2 over 2, because we've moved square root of 2 over 2 in the x direction, square root of 2 over 2 in the y direction. Well, now that we can see where that ordered pair comes from, we know that, and since we know that that angle measurement is still a 45-degree angle, we also know that the radius of my circle did not change. It's still a radius of 1. Then the sides, the value in both the x and the y direction, let me put my line back here, the value that I've moved in both the x direction and then the y direction is still going to be the square root of 2 over 2, except I'm moving in the negative x direction, that amount, and still positive in the y direction. Again, in the third quadrant, we know we have this angle of 45 degrees. We haven't changed the radius of the circle. So this location down here has to be negative square root of 2 over 2 and negative square root of 2 over 2. So the if you will, the legs of the triangle are technically not changing. It's just the location as I move around the unit circle changes the value of x and y by a positive or negative amount. So in the fourth quadrant, we would have a positive x followed by a negative y. Still, square root of 2 over 2 and negative square root of 2 over 2.